In this video, which is part 3 of bubble sorting in Scratch, we will be learning how to do bubble sort in Scratch. So, how does bubble sort work? Bubble sort sorts adjacent pairs of elements that are out of order. This process repeats until the array is sorted, which is when no swaps are made in so-called one round. For example, let's use this array. We find out that 49 is less than 92, so we do not swap them. 92 is greater than 91, so we swap them. Since we have made a swap, we realize that the array is not sorted. Then 92 is greater than 80, so we swap them. 92 is greater than 57, so we swap them. Now, let's do it again, since the array is not sorted. 49 is less than 91, so we do not swap them. 91 is greater than 80, so we swap them. At this point, we realize that this array is not sorted. Now let's compare the next group of elements. 91 is greater than 57, so we swap them. 91 is less than 92, so we do not swap them. Now let's do another round since our array is still not yet sorted. 49 is less than 80, so we do not swap them. 80 is greater than 57, so we swap them and realize that this initial array is not sorted. 80 is greater than 90, 80 is less than 91, so we do not swap them. And 91 is less than 92, so we do not swap them. Now, let's do one last round since the array at the beginning of this round was not sorted. This reduces the amount of time taken since we do not have to individually check whether the array is sorted. So anyways, 49 is less than 57, we do not swap. 57 is less than 80, we do not swap. 80 is less than 91, so we do not swap. And 91 is less than 92, so we do not swap. Since we have made no swaps, we realize that in this round, we realize that the array is already sorted. Now, let's go ahead and implement this bubble sort into Scratch. First up, we'll draw the array, and we'll set sorted to 0. This is to prevent this repeat until block from immediately terminating, since we have to swap elements until we think that the array is sorted. So initially, we'll think that it's sorted, and after that, we'll iterate over the adjacent pairs of elements by setting j to 1. We'll repeat this many times since there are length of array -1 elements in the concept pairs of elements that are adjacent. So if they're out of order, then we realize that the array is not sorted, and we'll swap them like this. We'll set temporary to this item j plus 1 of the array, replace item j plus 1 with item j, and replace item j with the temporary. Now we'll wait this amount of the seconds. The reason why is that on average, the amount of swaps needed is around half times the square of the length of the array. And therefore, since I prefer this simulation to visualization to take the same amount of time, I'll have to make it wait for this amount of seconds. Of course, it's up to personal preference, and you can choose to make it wait a different amount of seconds. After that, we'll draw the array so as to let the user see that the elements are being swapped. We have come to the end of the video. Before you leave, please remember to subscribe to the channel. Thanks for watching.